Elixir is a functional programming language, and at its heart are, of course, functions. In this episode, we'll learn how to create functions in Elixir and see what they can do. So let's start by defining some functions. Now in Elixir, functions are organized into modules. Let's create a module to help us do some simple calculations. We'll call it calculator. I've added these functions off camera, but let's walk through them. Our first function, squared, takes a variable x and multiplies it by itself. Product of multiplies two variables, x and y, returning their value. And sum of adds two variables, x and y, and returns their value. Now that we have some functions defined inside a module, how can we test them out? Elixir comes with a read eval print loop, or REPL, called IEX. Let's start up IEX and call the module we want to be included, in this case calculator.ex. In order to call a function in Elixir, we want to use the module name, in this case calculator, and then the function we want to invoke. We'll use squared here. And we'll pass in any arguments the function expects. I'll give it a 4 here. And great, it returns 16. Now let's call product of with 4 and 2. Finally, we'll call our last function, sum of, with 1 and 1. Great, all the functions from our calculator module return the values we expected. Now let's add another function to our module. Going back to our module, we'll add a function named subtract that simply subtracts y from x. With our function saved, we'll go back to IEX, and instead of restarting our IEX session, we can reload our calculator module with R and then calculator. Now let's call our subtract function, and perfect, it returned 2. Elixir also supports private functions, which can only be accessed from the current module. Let's go back to our calculator module and update our subtract function to have a private function called doSubtract handle the work. In order to define a private function, we'll use def_p and then the name of the function. Functions in Elixir also support another great feature called guard clauses. Let's add a guard clause to our subtract function that prevents a negative number as a result. To do that, we'll add when x is greater than or equal to y. When this clause is true, our doSubtract private function will be called. Now we need to add another function to handle cases where y is greater than x. And in those cases, we'll just return a message saying x needs to be greater than y. Let's go back to IEX and take our updated subtract function for a spin. We'll reload calculator. Now we'll try a case where x is greater than y. And great, we expected 3. Now let's try y being greater than x. And great, our message was returned. A benefit of using Elixir is that since it's built on the Erlang VM, we can call Erlang functions right from our Elixir code. Now, one common use case you'll see is if we need to sleep for a period of time in our program. We need to use Erlang's timer module. To call an Erlang module in Elixir, we'll use a lowercase atom. So for timer, we'd use the atom timer and then call the sleep function, passing in how long we want to sleep, in this case for 1 second. Another way we can use the timer module is to alias it. Here we'll alias timer as timer. Then we can update this to timer.sleep for 1 second. We'll go back to IEX, reload our module, and if we call the subtract function, we see that it sleeps for 1 second before performing our calculation. Elixir also supports another type of function, anonymous functions. Let's create an anonymous function that does the same thing as our squared function. Let's store this function in a variable named squared, and to define the anonymous function, we'll write fn and then set any parameters we want the function to have. In this case, it only needs 1, which we'll call x. Then inside our function, we'll multiply x by x, finally closing our function with end. We can use Elixir's kernel function isFunction to check if our variable is indeed a function. And great, it looks like it is. Anonymous functions are called a little differently, with a dot between the variable and the parentheses. This makes it easier to distinguish between named and anonymous functions when you're reading Elixir code. We can also use the ampersand or capture operator to create anonymous functions. Ampersand1 represents the first argument passed into our function. If you needed multiple arguments, they would be represented as &1, &2, 3, and so on. We'll call our new squared function in the same way with a dot. And great, it returned 25. The capture operator also allows us to grab a named function from a module. Let's test this out by capturing our subtract function in a variable named subtractor. We'll wrap calculator.subtract/2 in an ampersand. The /2 refers to a function's arity, or how many arguments a function accepts. In this case, it's 2. Now our subtract function is captured in the subtractor variable, and calling it with both an x value greater than a y and a y value greater than an x returns our expected result. Another trick when defining anonymous functions is we can also return different data types. To return a list, we'll use square brackets in place of parentheses, and to return a tuple, we'll use curly brackets. That's it for our intro to Elixir Functions. I hope you enjoyed it and happy coding.